A rocket rises from the deserts of China, carrying more than astronauts. It carries a vision. Shenzhou-20 marks a pivotal leap in China's bold quest to land humans on the moon by 2030. This mission delivers 3 crew members to the Tiangong space station for 6 months of groundbreaking experiments in biology, physics, and next-gen space tech. But beyond the science lies something greater, proof that China's lunar ambitions are no longer distant dreams. In this video, we reveal how Shenzhou-20 moves the mission forward and what it means for the future of space exploration. The Shenzhou-20 mission represents China's 35th crewed space flight and the 5th during the application and development phase of its space station program. The crew comprises Commander Tiangong, a seasoned astronaut with 2 prior missions, Shenzhou-11 and Shenzhou-14, and newcomers Chen Zhongrui, a former Air Force pilot, and Wang Jie, an engineer from the China Aerospace Science and Technology Corporation. Their launch aboard the Long March 2F rocket is scheduled from the Jiuquan Satellite Launch Center, located on the edge of the Gobi Desert. During their 6-month tenure aboard the Tiangong space station, the crew will undertake a series of complex tasks. These include conducting experiments and technical demonstrations across various disciplines such as space life sciences, microgravity physical sciences, and new space technologies. Notably, they will study the effects of microgravity on organisms like zebrafish and planarians, aiming to advance our understanding of biological processes in space. Additionally, the crew will perform extravehicular activities (EVAs) to install space debris protection devices and retrieve external payloads, ensuring the station's continued functionality and safety. The mission also involves receiving the Tianzhou-9 cargo spacecraft and the Shenzhou-21 crewed spacecraft, highlighting the station's role as a dynamic hub for ongoing scientific research and international collaboration. These operations are crucial for maintaining the station's functionality and preparing it for future missions, including those aimed at lunar exploration. Tiangong's leadership is particularly noteworthy, given his extensive experience and previous role in constructing the space station during the Shenzhou-14 mission. His presence ensures a wealth of knowledge and expertise, which is invaluable for mentoring first-time astronauts and ensuring mission success. China's aspirations extend far beyond low Earth orbit. The nation has set an ambitious goal to land astronauts on the moon by 2030. Achieving this objective requires meticulous planning, technological innovation, and a series of preparatory missions. Central to this plan is the development of the Long March 10 rocket, designed to transport astronauts and cargo to lunar orbit. The mission architecture involves 2 separate launches, one carrying the Mingzhou crewed spacecraft and the other transporting the Lanwei lunar lander. Once in lunar orbit, the 2 spacecraft will dock, and astronauts will transfer to the lander for descent to the moon's surface. In addition to transportation, China is focusing on establishing a sustainable presence on the moon. Plans are underway to construct the International Lunar Research Station, ILRS, near the moon's south pole. This space will serve as a hub for scientific research and exploration. To power the station, China, in collaboration with Russia, is considering building a nuclear power plant on the lunar surface, supplemented by solar arrays and infrastructure for electricity and heating. The ILRS is also designed to support both robotic and crewed missions, featuring autonomous systems that can conduct maintenance, exploration, and data collection when astronauts are not present. These initiatives are not merely about national pride. They represent a strategic move to secure a foothold in the next frontier of human exploration. By developing the necessary infrastructure and capabilities, China aims to become a leading player in lunar exploration and utilization. The country also intends to deploy robotic systems for cargo prepositioning and automated construction, ensuring astronauts arrive to a partially functional base. The Shenzhou-20 mission plays a critical role in this roadmap. The experiments and operations conducted aboard the Tiangong space station are designed to simulate and prepare for the conditions and challenges of lunar missions. For instance, studying the effects of microgravity on biological organisms provides insights into how human bodies might respond to extended stays on the moon. Similarly, testing new space technologies and conducting EVAs contribute to the development of equipment and procedures necessary for lunar exploration. The Tiangong space station, whose name means Heavenly Palace, is a testament to China's commitment to independent space exploration. Since the launch of its core module, Tianhe, in 2021, Tiangong has been continuously inhabited, serving as a platform for scientific research and technological development. Tiangong's modular design allows for the addition of new components and laboratories, enabling a wide range of experiments in various scientific disciplines. The station's capabilities are continually expanding, with each mission contributing to its evolution. For instance, the Shenzhou-20 crew will receive the Tiangong-9 cargo spacecraft and the Shenzhou-21 crewed spacecraft during their stay, highlighting the station's role as a dynamic and adaptable research facility. These incoming spacecraft are part of a broader logistical strategy that keeps Tiangong fully operational and well-supplied, simulating the kind of supply chain that will be essential for longer missions to the Moon and beyond. Beyond hardware, the Tiangong station is also a proving ground for human endurance and crew coordination. Long-duration missions like Shenzhou-20 test the psychological and physiological resilience of astronauts. This is crucial because future lunar or Martian missions will require teams to work together in confined environments under high stress for extended periods. The crew's ability to function as a tight-knit, efficient unit is just as vital as the scientific experiments they conduct. And unlike the ISS, which relies on multiple nations for maintenance and support, Tiangong is fully independent. This autonomy ensures China can pursue its space agenda without being subject to foreign policy fluctuations or external funding constraints. Yet China has extended offers for international collaboration on Tiangong through research programs and scientific partnerships, especially with countries that haven't traditionally had access to orbital facilities. With missions like Shenzhou-20, Tiangong is not just fulfilling its intended role, it's surpassing expectations. Each crew rotation builds on the lessons of the last, turning the station into a cumulative success story. The knowledge gained here doesn't just stay in orbit, it flows down to Earth in the form of innovations in health, materials science, and AI, while also moving upward to inform the technologies that will power the next great leap, lunar colonization. China's Shenzhou-20 mission isn't a destination, it's a bridge between the earthbound limitations of today and the interplanetary ambitions of tomorrow. With Tiangong as its base and the Moon in its sights, China is methodically building the future of human spaceflight. From biological experiments in orbit to lunar-based blueprints and nuclear energy on the Moon, every piece is falling into place. Shenzhou-20 is a mission of many firsts and a foundation for many more. As the rocket ignites, so too does the next chapter in humanity's journey beyond Earth, and China is riding it in bold strokes. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, SpaceEyeNews.com. Thank you for watching, and see you next time.